if we go back to the poem and we read it, there's the opening line, and then there's the response on what the germ has. So it's any style of life is prim, the fairy is rosy of glow. So the fairy is rosy of glow is actually referring to the chemical effect that's happening in the bacterium itself. But maybe you can explain, Matt, how the response happens in this bacterium.
So the genius of this is that, like, it's not just us reading the poem. It's not just that we're reading any style of life is prim and then we're also reading the fairy is rosy of glow by following the code that's been laid down, but actually the bacteria itself is reading the poem. This is my DNA strand. I kind of want a bit more space, so I'm gonna go over here and move. I'll just do it down here. So when you've unzipped your DNA strand, remember DNA is this huge long sequence. It's your enormous library of all the information inside your body. So let's say that this is the bit of DNA that we've unzipped, and this is the gene for the poem. So what will happen is, and obviously the gene is on both sides, but the body will only actually read one side. So the body will read the side that we read on the left of the poem. So when I say body, I mean bacteria. The bacteria will read this side, and in doing so, it will collect together loads of these little floating bits of DNA, and it will rewrite the poem itself, but the opposites, well, the reflection of the poem, because for every time it has a C, it will connect with a G. Every time it has an A, it will connect with a T, and so on. And it will basically make a little copy or a little recipe of this poem. Yeah, the body will take this little bit of copied DNA and send it to the factories, which are called ribosomes in the body, that will make proteins. So the protein making things inside the bacteria will then produce the protein which is coded for by the poem, which happens to be a fluorescent protein. Fluorescent means that it's kind of glowing, right? Now, quick thing before I hand back to Phil is that anything fluorescent in nature is poisonous. Don't eat fluorescent stuff in nature. It's always poisonous. There have been loads of chefs who have been thinking, oh, wouldn't it be cool if we could have a fluorescent dinner? No, all the fluorescent stuff is poisonous.
Initially, these were implanted into E. coli, but E. coli then started taking the poem and rearranging it and mutating it. And in a sense, Christian Book wanted to have a place that would store his poem permanently, but he didn't create the first bacteria that could then write a poem with its response. So for every letter, any style of life, the fairy is rosy. If you look, A matches to T, and then N matches to H in the alphabet and in the xenocode. The germ, the bacterium, started to fully distort the text, and then it broke apart and started editing it and started making new poems all over the place, which is cool, but it isn't what he was trying to do. So instead, he thought, all right, I'm not going to use this poo bacterium, E. coli. I'm going to find a bacteria that will last. And I don't know much about these, but he used what's called an extremophile. Matthew, you know a bit about extremophiles, right?
So before we go on to extremophiles, does anyone know why E. coli was changing the poem? Does anyone know what E. coli was doing that was continually editing the poem? So Rebecca Khan is coming with tardigrades. Tardigrades are one of my favourite extremophiles. We'll talk about extremophiles in just a sec. But why would it happen that E. coli would edit the poem?
Rebecca just said it can adapt.
Yeah. Okay. Great.
Or mutating.
So brilliant.
All caps, please. Okay, Jeff, we can do all caps, but you need to stop doing your acrostic poems.
So yeah, it's all about adaptation. So most of life on Earth has evolved to allow things to adapt quite quickly. So we're good at maintaining the DNA inside our body, but we're also good at creating chaos within it. So if you try and it's the same goes for most bacteria. So if bacteria is coded to have a certain sequence of DNA, then whilst it will try to maintain that sequence, it will also copy random different versions of it. So DNA is made of sections, like long sections called This is going into quite advanced biology, so I'll skip over this quite quickly, but just to show people who are interested. DNA is made of long sections called exons and introns. And basically, the exons are the useful bit, the bit that we actually use to make stuff, and the introns are just kind of like spam in between. They're just like filled in space that seems to not do anything. And all living things are supposed to be experts at chopping out the introns and just using the exons to make the stuff that we actually want to make. However, when you have a bacteria that's trying to evolve and trying to adapt, it will randomly chop out exons by accident. So you'll basically get bits of the poem that will be removed and just thrown away. And then that might be more beneficial for the bacteria. And then the bacteria, because E. coli is like, maybe I don't like this poem, I think I can do it better. And so essentially it kind of cuts bits out and creates randomness in it so that it can evolve.